Alright guys, in today's video we're going to be doing what is probably going to end up being an electronics repair. We're working on this Fellowes PS-14Cs paper shredder. And the problem with this unit is it runs okay. Obviously it's off now. It runs okay in the reverse direction, but it runs continuously when you turn it on. The safe sense works, but it shouldn't run all the time. It's supposed to only come on when you put a piece of paper in. And the reason for that is typically held in right here with these sensors. So you can see here there's a sensor. If we zoom in, it's kind of like a diode looking device. And then there's one on the opposite side. And then if we look at this little cover, there's a hole for the light emitted by that to shine through. This is an infrared emitter, and then there's a detector. Now the first thing you can try with this kind of problem is you can come in with some compressed air. You can try to clean this out. You can also come in, use some lens cleaner on a Q-tip, and you can try to clean these guys. But in our case, they're inoperative. If you have an older kind of iPhone or iPad, it'll sometimes show up these infrared lights when they're working. We've tried that too, and we're getting nothing. So we suspect that either the emitter's dead, or the receiver's dead, or the circuit that drives them has got a problem, so they're both dead. So we're going to take this apart today, and we're going to try and do further diagnosis on which of those components needs to be replaced to fix this problem. Now, why do we care about it? It runs. Why would we care? Well, what will happen on these units that have a temperature sensor is they will quickly overheat if you leave them running continuously. You need this to have a break in between pages if you're shredding a stack of information. Otherwise, the motor will overheat, and it doesn't take long for the motor to overheat before it shortens the lifespan of the motor. So we need to fix this. All right, so to get this apart, we're first going to go around here on the back. We're going to make sure that the power is off on the master, and we're going to de-energize it by unplugging it. I'm going to take the paper bin out of the way. And then we're going to flip this over and we're going to see how this comes apart. You see we've got screws all the way around the perimeter here. I don't see any obvious way that this base is attached. So let's just take a guess and say this all comes off together. We can see down here these are Phillips screws. There's one, on this particular model, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So what I'm going to do is I'm going to pull these 11 Phillips screws out and see if that helps us get this taken apart so that we can get a look inside. So I'm not going to bore you guys with that. I'll take these all out. Probably need to have a magnet to actually pull them out of these deep holes, and then we'll come back. All right, last one. Okay, so we got all these fasteners out between the Phillips and a magnet. You can see that did separate something. I left these two on because I thought that they might be holding something on the case, but I'm going to go ahead and take these two very high mounted, close to the surface fasteners out as well, because we still have some resistance. I was expecting this guy just to come right off with the perimeter bolts, but let's see what this does. Okay, so as suspected, this is all one piece and comes off. All right, so now we've got access to the motor, the blades. I got a little insulator here, and what we're after is the circuit board. So there's the circuit board that drives everything. Don't want anything to fall out here. Just trying to see proximity-wise what we're looking for. So it looks like in order to see those sensors, it's going to be one of these two sets of wires here. And we're going to have to take this assembly out to get to them. So let's see, is this just something that sits in here? Or is it plastic welded on? Okay, no, it just sits in here. All right, great. All right, so we just need to remember that we have this guy, there's an insulator that we're going to have to put back when we get done. And this should just lift out. And you're going to have all the paper mess. Again, guys, make sure everything's unplugged. All right, here we go. So here's the wires to our emitter, the blue and the white, and then the blue and the orange are the wires to the detector. So the first thing I'm going to do is I'm going to get this guy out of here, and we're going to see about testing the emitter. All right, so I don't want to break this little mount here, so let me find a way to situate this assembly so I can get my other hand free, and we'll go and pull this out. All right, before I get back to what we're after here, let me just show you over here on the motor assembly. These gears have got a lot of grease on them, right? I don't know if you guys noticed, but I put my hand right on there and had to get cleaned up. So if you don't want to wear gloves, make sure you keep an eye of where this is and don't touch it. And also keep all the paper debris out of these gears or you're going to have a big job cleaning all that up. Let's come back over here, right? So I'm going to take a small plastic tool here. And what I'm going to do is I'm going to try, without breaking it, I'm going to try to spread this little plastic retainer that's holding this guy on. Let's see if we can have some success. There's that one. This one seems similar. He's wedged in there a lot tighter, though. I may have to get a different tool to prise him out. And then this guy here, just when you put everything back together, this is a ground wire. This guy's going to lay against one of these metal rods, whichever one is closest to it. Just going to kind of lean against it. All right, I'm going to need a little pick to work him out of there. But now with these out, what we're going to also do is we're going to come over here and find the motor wiring. And we're going to disconnect the motor. Let's see, black, red, gray, yellow. Black, red, gray, yellow. So we're going to disconnect the motor so that we can power this guy up without all this mess going, so that we can start doing some debugging of this circuit board. All right, let's see if we can get this guy out with this small pick. Nope. He's really wedged in there. Nothing we're working on here, guys, is supposed to be serviceable, obviously. The idea is go buy a new shredder, but it's not how we do things here. All right. There we go. All right. Nothing damaged, nothing broke. All right, good. All right, if we kind of zoom in where our leads come in, I'm just pulling back some of this hot melt glue, and we can see that by the orange and blue wire it says RX1. So I believe that means receive. And then the white and blue wire, we pull this back from here. We can replace all this later. Try to get this out of here. see right under this guy. Hopefully it's coming out for you guys. I can see TX1 right there. Right. So we got transmit on white and blue and receive on orange and blue. So now we've confirmed the function of these two devices. I'm going to just go ahead and pull the rest of this old hot glue out of here, and then we'll come back. All right, guys, got the motor disconnected from the board, of course, so that we can do some tests without it running, which would be dangerous with the shredder outside of the assembly. And we took some time to, if you come over behind this plastic standoff, we took some time to pick out all the rest of that residual hot melt glue. We'll replace it when we figure out this diagnosis, but for now we just wanted that out of there so we can probe. In order to get this test to work with the motor disconnected, there's a couple of things we got to do. We're going to have to, first of all, overcome this micro switch, which is used to detect whether the paper bin is installed. If it's not installed, it won't energize anything. So we're going to come over here and use a rubber band to accomplish that. So that'll keep this switch depressed while we do our tests. And now if we plug this guy back in to AC power, and if we do the main power on here, and then we pick this up and hit auto, the green light lights up, so now everything's energized, so we should be able to come in here and do some tests. Before we actually do that, though, let me stop for a second, show you what we're going to be doing. So we've got this detector I have. I'm going to show you two ways. This is the first way. This guy can detect infrared. So if I have like a TV remote here, this is the collector here that can detect from the emitter and the transmitter of the remote, and it can tell that you got something. But another way you could do this if you don't have that tool is you could just grab an old iPhone or iPad, this over here, and typically the forward-facing camera, the one that's the selfie camera, doesn't have an infrared, and the one that is outward-facing does have an infrared filter. So you want to use the selfie-type camera or the forward-facing camera in order to not have there be any filtration of the infrared. And now if we hold a remote over here, you can see that little flashing purple is the infrared LED on the remote. So that's two ways that we can test this. So now let's power it on and let's see if we got anything at all. So I'm going to see if this guy is it. Almost. Maybe a loose connection. I could have swore he just beeped there, right? Get nothing from this guy. Maybe it's just my imagination. I could have swore we had a beep out of that. Well, I'm not getting anything on either of these. So for sure, the emitter is burned out. All right, so this is everything disassembled that you can disassemble without doing desoldering. So all the connectors are unplugged at this point. And with this opened up, we have the ability to come in here and tone out where everything goes, right? So just putting our meter in continuity mode where you can hear it beep, we can come over and we can map stuff out. Like we can see, okay, this white lead here, and we've gone through the trouble of mapping out that goes over to R22, right? And then R22 goes over to this link, J9, right? And then J9 goes up to J11, and then J11 goes up to D14, right? And so we mapped out the whole circuit. And you can take like a flashlight, really powerful LED flashlight, and you can shine it up under here to help you see the traces. And flipping the board back and forth, you can map out. All right, so we've mapped out what the circuitry is for these two photo detect pieces, right? So this top piece here is our blue and white for our photo detector. And so you can see here that circuit goes through what's obviously an LED, an infrared LED, goes through R22, J9, J11, this diode D14 into the collector of Q2. And then off the emitter of Q2 is R38, and it goes over here to a ribbon cable, and this is actually going to be the jam detect LED on this lens. So some other piece of circuitry, when you get a jam, is going to trigger the base, which is then going to share current here down for the LED on the jam. So these are the two, the paper detect and the jam are the two LEDs here. Now on the bottom circuit, this is our orange and blue. I've drawn this in as a photodiode, but I'm not really sure it is a photodiode. It could be a phototransistor. We're going to have to do some voltage checks to be sure. But on the blue side, we've got this resistor network coming off C18, and then we go through through the detection device, the receiver, R20, J10, D15, over to pin 2 of the LM324. The reference voltage is on pin 3, and then also connected to this is R26, C14, and then we've got this whole other set of circuitry here. So this complexity really tells me this is probably not a photodiode for the paper detect, but probably a phototransistor. The other thing is, when I took a look down here at C18, one of the things we found was C18 was really out of spec. So I had to pull it off. I pulled it off and took a check. If you zoom in here, you can see this is supposed to be 0.22 nanofarads. So this one we're going to replace, and then while I was in there getting that one, if we zoom into this little guy here, you can see he's all puffy on top. He's bulging, and he's supposed to be 470 microfarads, this electrolytic here, but he's also out of spec. So I'm going to go through all of the electrolytics and make sure they're in spec so that we get the right power for this circuitry, but then we're going to need to kind of do some measuring to see what this is. But I'm pretty sure this is probably a phototransistor rather than a photodiode. So let's go check that out. All right, so I've gone through all these electrolytics and I've measured them all, and only 6 of them were in spec. So I've pulled them all out and we're going to replace them all. That's not surprising with something this old. That's a good idea while you're in here. So this is cheap. This whole handful of parts I got in my hand is probably $4, maybe even less. All right, so now we're going to go in here. There's no point in showing you the soldering, let the mother see there, but coming in here, repairing this hot glue. It's nothing more than doing something like this, right? Just want to make sure that we sufficiently got it all over to hold this guy in place. So the only purpose of this hot glue is to keep everything kind of in a fixed position so it doesn't have any stress on it, so we don't get any more breaks. That was the original reason the factory did it, so we want to make sure we recreate that. Try to get it back in here before it fully dries so that it can dry in a happy place. And we'll just start getting everything reconnected and resume our repair. So the first thing we're going to do is remove the heat shrink around this guy. Try not to nick the leads as we do with this X-Acto knife. And then we'll replace this heat shrink after we desolder this guy. All right, so now we're going to need a piece of shrink wrap on both the anode and cathode side. They do that, I guess, just to keep it from shorting, obviously. But we're not going to need to remove all of this. We just need to get enough to desolder wherever it's attached down here at the base. All right, we're just going to use a portable unit for this. I don't think it's like wrapped around here or anything like that. Yep, it's just soldered on without any attempt to mechanically bind it together. Very fragile. This one I can't really see where the the wire is at. So I'm going to kind of loop it around this standoff to give me some pressure. There we go. All right, and then the next thing we're going to do while we let the soldering iron cool off a little bit, we're going to come over here and we're going to grab some appropriately sized skinny shrink wrap. Whoops. Fish this guy out of there. So all we're going to do is we're going to cut something like this to size, right? Give it a little bit extra, like maybe like that. And do the other one the same length. And we should be able to run this. Hoping we can run this down this wire, otherwise I might have to use something a little thicker. Yeah, I think we can get it down this wire with a little bit of some lubrication, a little bit of silicone. We should be able to pull it down like this. We'll solder the new one back on, and then we'll also need a slightly larger piece to make up for the original outside when we took off. And I think maybe something like this. Nope, like this, to go around both of these together. Yeah, we'll just cut a piece of this to run up the whole length of it as well. So let me get that sized and cut. All right, now that we have desoldered the old detector device on this receive circuit, let's see what it was, because we really don't know if it was a photodiode or a phototransistor. So blue's negative, orange is positive. We've got the voltmeter sitting down here. Let me see if hopefully it lights up where you guys can see it. We're going to do two measurements. We're going to see what the voltage is, and then we're going to see what the amperage is. So let's go ahead and turn this guy on. Go real quick here before he heats up. And we're getting about 8 volts. 7.99 volts. 8 volts. DC. So that's how much voltage is moving through here. So even reverse bias, that's a lot for a photodiode. But now let's switch to amps. And we turned off the motor so that, milliamps rather, so that it doesn't burn out. All right, so now we're going to measure in this direction. So when we do the amperage, the motor should stop because that's going to replicate the effect of the circuit. So we've got the switch on auto here. I'm just going to turn the main power switch on. Motor's going. Motor stops. 1.31 milliamps. So that's the effect of the circuit. Whatever gets put in here has got to carry about 1.3 milliamps, and when it conducts, that's going to cause the motor to stop, and when it stops conducting, that's going to have the motor go. That's how this circuit works. So when it detects paper and then it runs for a short period of time, there's a 555 timer on here that might be part of that circuit to do that. So now we know how much it's pulling. We know what we need to get in terms of a replacement part. This is a phototransistor type device. A photodiode couldn't handle sinking that much current. And remember when we took the voltage reading on the 724 op amp over there, it was also 8 volts. So that's probably what we're going to have to be syncing for the reference through this. So now we know what we need. Let's go get the correct parts for it, and we'll get a matching emitter to go on the blue and white circuit. All right, so this is the part that we're going to end up going for the detector or the receiver. It's an Osram SFH314FA, and we're actually going to use the 2/3 version, but this is a black epoxy 2-pin phototransistor. And, it looks like a photodiode, but it's actually a phototransistor. It's an NPN phototransistor. And again, it's T1 3/4 is 5 millimeter, which is the size that we need. And then I mentioned we got the 2/3 one, the FA 2/3, so that we sit in this milliamp range. You notice we took a reading before at 1.3, so we want to fall in with something that will be happy with that range, and this one would be even higher than we need. This one is plenty, so we'll be fine with this guy. And then he is wavelength-wise, I think he's wavelength-wise is 850, yeah, 850 nanometers. 850 nanometers. So we're going to need a matching infrared LED in water clear, and what I'm going to go with that one is a light-on HSDL 4261, again T1 3/4, which is 5 millimeter, and this one's 870, but it's close enough. I mean, it's just 20 nanometers off. Sometimes, you know, you can't get them dead on, but this one was a good price for the quantity I was looking for along with that. So that's what we're going to be hooking up. We'll get these parts ordered along with our capacitors, and then we'll get this guy back in operation. All right, here's our light-on HSDL 4261. We're going to solder this on here with the long anode end on white and the short cathode end on blue. All right, we're not going to shrink the heat shrink down just yet. We're going to test it first. Now, if you remember from the data sheet, this is a high power infrared LED. We can't see it, so it's super bright. If it's like a super bright or super bright white or bright red, you know, you'd squint. You won't be able to squint with this. So I'm going to use a little piece of a cardboard straw and a little piece of black electrical tape, just kind of make a little shroud for it, just so it goes only in the direction we're pointing it at. I'm going to go ahead and put our auto switch on. I'm going to take our infrared detector, turn it on, power this guy up. It's kind of there. Not sure why it's not more. Oh, there it goes. All right. Maybe I just wasn't holding it properly. Looks like it's working, but we won't solder it. I mean, we won't heat shrink it until we test it with the transistor. So now we'll switch this over here and we'll solder that on. All right, we zoom in here. We've got our phototransistor now that we're going to put on our OSRAM. And longer lead on these is the collector. Shorter lead is the emitter. And if it doesn't have a difference, hopefully you can see this, but the emitter side is going to have a flat edge to it. And what we're going to do for this connection is we're going to put the collector, the longer lead, on blue, and the emitter, the shorter lead, on orange. That's how we're going to connect these. So let me get this set up and we'll solder this guy in. All right, we've got this guy soldered on as well now. Now let's give it a test. So we're going to use our little shroud here. Can't remember if I hit the auto button before. Nope. Let's put that back on. Turn her on. All right. She shut off. Break the beam. Runs. Connect the beam. Stops. It is supposed to run for a little bit according to the owner's manual. Break the beam. Restore the beam. All right, we fixed it. So at this point now, what we can do is we can be sure that this is all right. Now we can come in here and melt the heat shrink tubing. This is just a butane torch with a little hot air gun attachment at the end. Okay, once we see that outline of the leads on that side, we'll just double down on this side. I don't like getting it near the epoxy of the LED. You never know if it's going to damage something. Okay, we'll let that cool. We'll do the same thing on the phototransistor now. Okay, we'll let that cool. Now we'll put this outer piece on. Okay, and the same thing on this one. Trying to get it right to the edge of the epoxy without heating the device itself up. All right, this looks good. So now we can take our LED, reroute it the way it was. If we come on the other side, remember that it went into this little hole here. Like that. So we make sure it's nice and secure. And then the same thing with this guy. I think he went in here, routed around this standoff, and then he also, whoops, snapped in. All right, we're just going to bend those leads a little bit. Now we're going to take this rubber band that we were using on the paper detect micro switch. Don't forget to do that. Going to vacuum some dust out from in here, and then we'll flip the motor assembly back on and we'll put it back together. All right, so we just flipped the motor assembly back over the way we flipped it out. You want to make sure that these standoffs are coming through here, 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 and also the three on this side, here, here, and here. You want to watch for these little feet on both sides sitting in here, and these little cutouts. There's going to be two on the other side as well. And then right down in here, hopefully there's enough light, we want to get this static electricity ground back touching this chrome rod, right? This little ribbon guy. Hopefully there's enough light in there for you guys to see that. And that just needs to make contact under here with that chrome bar. That's it. All right, so now let's go put our base back on. When we sit it down to put the base back on, and again, watch out for this grease around these gears. It's just like everywhere. Remember that we've got our little gasket, so we want to set that right on here. And then there's a little switch that we want to make sure is sitting back in. Make sure the power cord is sitting, and it is, and make sure this power switch didn't pop out. All right, let's go get the top and put it back on. All right, so we've set the base back on. Remember, in the screws, these two that have the captive washer, they're the ones that go in the center where you had that black gasket. And then the others are just going to have to find the hole here at some point. And then the others are just going to go in all of these other openings, just the same as when you took them out. And then you're just going to snug them back down. They're all the same length. They're all the same. Just make sure you get them in each of the holes so that they're all used up. And now we're just ready to tighten everything down. All right, we got everything back in. Let's power it on. Want to make sure some of the safety features are working. So our bin open detect switch, make sure that's red and that it closes. We want to make sure now if we turn this guy in reverse, he still works. We want to make sure that our safe sense is still working. So if you make contact here, this light comes on and the motor stops. So that safety feature is working. And now if we turn it on, light comes on, runs for a brief time, shuts off. We're going to run through a lubricant sheet since we've had this open for a while. Should shred it and shut off, right? So working perfect. So now if we take a piece of regular paper, perfect, all fixed. So now this won't burn out the motor by running continuously. How much did it cost to fix this? Well, all those electrolytic capacitors and the phototransistor and the photodiode, the whole set of parts was about $12. I think we spent maybe $6 or so on shipping using United States Postal Service. So was a worthwhile repair for the number of parts that we needed and the cost. For some reason our bin is not wanting to stay in there. Anyway, we're fixed. We're all done. This job is done. I hope this taught you how you can go about repairing any of your Fellowes Power Shred type series. This is the Power Shred 14CS, but that's the same board that's used in the 77CS and probably many others. If you got questions about what we did here or comments, leave them below. I'll try to answer and help if you have a question. If you found this useful, saved you some money, and got your shredder repaired yourself, go ahead and pay it forward and hit that like button. I'd really appreciate it. And as always, thanks for watching.